In this video, we're going to look at pyLDAvis, and we can use this to visualize the topics we learned in a previous video. So let's look at some code. We have install instructions here, pretty straightforward. Pip install pyLDAvis. We have the paper here, so Py stands for the Python implementation. This is the actual LDAvis paper, so you can read more about it here. And we can also look at the GitHub of the Python implementation. So what we're first going to do is load the stuff we saved in a previous video where we did LDA. So we're going to load our dictionary, our corpus, and our LDA. We get the familiar pattern warning. Now we're going to import pyLDAvis.gensim. Don't worry about the deprecation warnings. So now we're ready to get started. So we have pyLDAvis, gensim.prepare, LDA model, the corpus, the dictionary, and we're going to say sort topics equals false. What that means is keep the topics in the same order they were in gensim. And then we're going to do pyLDAvis.display. So let's first clear topics here. First, we get the most salient terms. So what this means is the terms that most kind of tell us about what's going on relative to the topics. And the things look familiar from my tweets that I recall. So I remember, dream, could, want, amaze, memory, article, video, coffee, robot, child, all things I tweet about. And we can also then now look at the individual topics. So we have topic 1, topic 4, which will be topic 3 we saw when we actually ran LDA, has watch in it for movies. And so you have a slider here, which tells you what's shown to be normalized based on how common the word is. So if you have the slider all the way to 0 for lambda, you're going to normalize based on how common the word is. So here, what we have is the relevance. What we saw up there is lambda times probability of the word given a topic plus 1 minus lambda, the probability of the word given topic, divided by the probability of the word. So more common words are going to be less important. So here, if we set lambda to 0, we've got the second term. If we set lambda to 1, then we're not normalizing. Recall that in the previous video, we did LDA for 5, 3, and 10. So here we are. We have it for 3 as well. Let's go ahead and run it. So we have our topics here. First one is dream. I do tweet a lot about dreams. Funny movie, tweet a lot about movies. And coffee. I didn't know I tweeted so much about coffee, but I do. So we have it for 10 as well. And so when you do this, you get 10 different bubbles, and they are plotted on a 2D space using PCA, so you can see that certain ones cluster together. And if they cluster together, that means they're kind of more similar about a topic. And up here, I defined some of these things that I'd mentioned before, the saliency, the relevance, what the lambda of 1 and lambda 0 means. So you have that as reference, although I just copied it from there, but it makes it a little easier to read. And the size is the measure of how important a topic is relative to your data. So this is a really nice way to visualize what you've done. Now, of course, with the tweets that we did, it has the advantage of being kind of personal, but the disadvantage is it's one person generally writing about the same kind of stuff, or at least in my case. In your case, you may have more variety in your writing, and your topics may be more salient. But as an exercise, you can visualize LDA and newsgroup data. And as we mentioned before, newsgroup data is 20 different topics. It's kind of ready-made for LDA, at least seeing how LDA works. Now, of course, LDA is what you use when you don't know what topics are in there. But as far as learning how LDA works, knowing that there are 20 topics and running it and seeing how it works will be a great exercise.